When you look at all these pictures I have here and you see all the different forms of motion, it really makes you think how often in our lives motion plays a huge role. And we're going to be looking at some notes that start to describe motion. Speed, velocity, and acceleration are ways we talk about how we move in the world. And we're going to focus the first set of notes on speed. And when I think back on my life and even currently, I think motion is one of the things that just draws us in. It captivates us. And for some of it's simple things like the rustling of trees in the wind or motion of animals. For me in my life, although those things did captivate me, I've always been drawn to sports. And just an example, this is a picture of me windsurfing at the Oregon coast. It's just such a crazy, cool feeling to be flying along on the water, jumping over the waves and riding them. For other people, it's different things. For example, my brother is a helicopter pilot, and he loves the feeling of flying. It just gives him a sense of freedom. And you know, I've tried to impart my love of motion, specifically of the ocean, to my daughter. You can see her just grinning ear to ear in this picture. She's cruising down the face of a miniature wave there. And even, you know, locally, mountain biking or being on a bike. I got above the clouds here on Roxanne. The valley, Medford was fogged in, but up there it was just beautiful. And flying down the hill on a mountain bike, it's just awesome. So I think we're all drawn to motion, transportation, or whatever it is. And so this set of notes is to introduce you to speed, to get you comfortable with some of the concepts that we use when we talk about motion. Yeah, some of you are going to wonder if I'm ever going to actually get to the notes on speed here, but I can't pass this up if you missed this in class. If you're into extreme sports, you gotta pause the video, type in this link right here. This is just crazy. It's called kite skiing. It's just a screenshot of that. You can see his skis right here. Here's a shadow, but he's attached to a kite. And I won't say much more than that other than watch it. And now we'll start our notes on speed. All right, and to the notes. I guess that was a kind of a long intro. We're going to describe what speed is here. And speed is, hey, when you can't find your own definition, go to the internet. I stole this off a web page. What is speed? Speed is a rate of motion. In simple language, how fast or slow you're going. And typical units for that would be meters per second. In America, we often use miles per hour. It could also be kilometers per hour. And let me delete that. So, again, it's a rate of motion. Rate of motion. And it is only a magnitude, and if you were in class, you learned that a magnitude is simply a number that tells you how big or small something is. And that's what speed is. So typical units, as I mentioned, in science class would be meters per second. There are other units. If it was a longer distance in the metric system, we'd use kilometers per hour. In America, you tend to use miles per hour for at least longer distances. And again, in my class, this will be the most common unit we use. This would be the second most common. Very seldom, except for maybe some examples to make it more real to you, we might calculate speed in miles per hour. And the formula for speed, and it turns out you can actually using this formula, it's actually just a formula to calculate average speed. The average speed between two different points is just simply distance divided by time. I use a little t because capital T is temperature. So that's the formula. So can do some examples here. It says you walk for 2 hours, you travel 8 kilometers, what's your average speed? Well, speed is equal to distance divided by time, and I list out my 3 variables here, and we'll just fill in what we know. We don't know what speed is. We know that distance is equal to 8 kilometers if we read the problem, and the time is equal to 2 hours. So then we just plug that into the formula. Speed is equal to 8 kilometers for every 2 hours. And then that would become 8 kilometers. Oh, sorry, it wouldn't become 8 kilometers. Let me erase that. That would become 4 kilometers for every, and as you guys know, when you divide, the bottom number always becomes and I hope you're saying 1 at home right now, 1 hour. Okay. And typically we would actually skip this step. It's an understood step. I chose to include it here, and usually we'd rewrite it this way. We would say 4 kilometers and then the division sign, instead of writing it like this, we just write it like that. And that is for every, we don't have to write the 1, it's understood, but we do write the hour, kilometers per hour. And you can see this is kilometers divided by hours here, and this is also kilometers divided by hours. So all this problem's saying is that if I went 8 kilometers in 2 hours, it would take me 4 kilometers to go. I would go 4 kilometers in 1 hour. It's just another problem. Actually, units here are a little bit funky. It says a plane flies 132 kilometers in 30 minutes. What's your average speed? Well, again, we can just set up the problem like we did before. We can say speed is, we don't know. The distance, I moved it out of view, can't remember, 132 kilometers. And that was in 30 minutes. However, it's probably better just to convert 30 minutes to hours. And so we're going to just do that conversion. I think I'm just going to skip the formal way to do the conversion for the sake of these notes and assume that we can do this one in our head. So this would be equivalent to 0.5 hours. Okay, so 30 minutes is a half an hour, or a 0.5 of an hour. So in this case now we're going to go 132 kilometers. Let me erase that real quick and do it right. We're going to have speed is equal to 132 kilometers divided by 0.5 hours. And that would end up being 264 kilometers in 1 hour, right? Basically, in a half an hour, if I go 132, you double the amount of time, 1 hour, and I go 264 kilometers. All right, now we're going to try to graph some motion things. So on your paper it says make a time distance graph for the following, and you'll see you have one that you're going to make for a constant speed, speeding up, slowing down, and being stopped. And you're going to make four tiny graphs, one here, one here, one here, and one here. And I'm going to minimize this and do this from a larger screen right here. So I have one graph set up. You're going to make 4 of them, and I'll just erase my line and start over for the different things. So for the first one, you're supposed to make a graph that has constant speed. So set up a little mini graph with time and distance underneath of constant speed. And I'm going to encourage you to stop the video after you draw your X and Y axis and label them like I have here. And try to draw what you think the line would look like lightly in pencil before I solve it for you to see if you end up with the correct line. So for a constant speed, you can restart your video if you paused it, obviously. I'm going to solve it right now. You would end up with a straight line. Okay? That would be a constant speed. Turns out that actually this is a constant speed too. However, the second line I drew, it just took longer to go the same distance. You'll notice if I draw across here, both of these went the same distance. But this line, it took longer to do so. This time took less time to do so. But anytime you have a straight line on a distance or time distance graph, that's a constant speed. So let me erase those, and now what we'll do is speeding up. What does it look like to speed up on a time distance graph? Well, again, you can pause the video if you'd like to try it first on your own. Turns up that speeding up on a graph or accelerating, positive acceleration, looks something like this. You get a curve line. And you go an increasing amount of distance for every given amount of time. If you put numbers on here, it might help to visualize it. So for example, let's just put a distance of 1, 2, 3, 4, and a time of 10, 20, 30, 40. If you look here, after 10 seconds, you didn't even go a half a unit over on this side. After 20 seconds, you've gone about a half. So after 20 seconds, you've only gone a half. But look what happened between 20 and 40. You've gone about 3.5 units of distance. So that's going further and further as time goes on, or speeding up. And let me try to erase these. Okay, what about slowing down? Well, you can pause the video again if you'd like. If you drew a line that looks like this, that's actually incorrect. That's not necessarily slowing down. That would be what a lot of people would initially think, but it turns out that a graph like this, you're already moving here, but if I level this line out, that's slowing down and actually eventually coming to pretty much a stop. Because if I put a distance here, I don't know, say 10, you'll see from about right here to right here, I really didn't go anywhere. I stayed at a distance of 10, and so that is slowing down. What about stopped? What does stopped look like? Well, stopped looks something like this. A straight line across. Again, put a distance here of 10, you'll see that as time goes on, I stay at a distance of 10. So I'm not moving anywhere, my distance isn't changing. And it turns out a lot of students find these pretty challenging, and the good news is this is just your first exposure to this. You're going to have some more chances as we go on the year here in our motion unit to practice this sort of graphing skill. Well, that pretty much concludes our notes over the speed section of your notes. We still have velocity and acceleration to do. And I think I'll just put a second video up for velocity. So if you have to watch the unit on velocity or the section on velocity, you'll just look at the YouTube when I get that up for that. So that takes care of the speed section. Thank you.